Welcome to the Archaeology Studio. Today's episode introduces digital site recording. By the end of this episode, you will be able to discuss the potential for digital site recording in archaeology, depending on the technology at hand and the research question being addressed. This presentation illustrates a few examples of digital site recording in real-life situations. The purpose here is to demonstrate the range of possible advantages and concerns, regardless of whatever particular hardware or software package might be involved. In practical terms, first we need to consider what kind of information we want to communicate, and then we can identify how digital site recording may or may not be advantageous. Generally speaking, digital files can handle more volume and diversity of information. And in principle, they can survive longer in storage when compared to their paper-based counterparts. Beyond those aspects, however, what does digital site recording allow us to do that we could not already accomplish? Overall, digital recording has allowed more efficiency of documenting sites. Standardized recording forms can be installed in portable devices, and furthermore, they can be linked with mapping data, digital photograph images, and other files. All of those tasks could be performed through conventional non-digital means, but the digital option greatly reduces the bulk of material equipment and the time needed for documenting each site. Site documentation records can be adapted for different technologies of global positioning receivers, digital notepads, and other devices. In my approach, I emphasize the observations of a site's location, its measurable dimensions, and its material contents. These factual records then allow logical inferences and interpretations about a site's age, its cultural functions, and potential new research questions. For one site recording project near the summit of Haleakala in Maui, archaeological sites mostly were visible on the surface and through shallow test pits. The site contents were easy to observe, and their overall footprints could be measured unambiguously. Some instances were more complicated than others, for example in caves versus open areas. Additionally, some areas contain greater density of material, such as in the concentrations of stone flaking debris. At Haleakala, the digital site recording replicated what I would have accomplished through conventional paper-based documentation, but with greater efficiency and more potential use. Additionally, digital photography images enhance the visual record of site settings and material constituents. The end result was a thorough descriptive record of the sites, capable of supporting more research purely with the documentary record. This kind of rudimentary documentation is absolutely essential in archaeology, but of course, much more could be explored. For instance, at the Ritidian Site in Guam, I have applied many different kinds of site documentation, including digital options, in order to address specific questions and problems. In this case, the effectiveness of digital recording has been maximized by first investing in comprehensive baseline documentation. Every site component was entered into a single comprehensive mapping system that could be viewed at any scale. The multiple elements could be examined individually, as groups, or in reference to other mapping data of the surrounding environment. This approach has accommodated new advancements in technology, such as the availability of high-resolution LiDAR imagery with further research implications. Several advancements have occurred in three-dimensional visualizations of site elements and even of entire landscapes. Once again, the best results were possible only after initially investing in the baseline site documentation. I was able to take advantage of three-dimensional landscape modeling by first recording all of the excavation findings with their depths, ages, and associated sedimentary units that furthermore could be coordinated with other environmental datasets. At a closer scale of individual site elements, digital photograph images can convey much more information than otherwise would be possible in conventional site maps and text descriptions. Digital storage now can accommodate dozens of pictures of every site and internal component. At a bare minimum, the vantage point of each photograph should be noted, and a standard scale bar can be visible in each picture. A photograph log can keep track of the date, time, name of the photographer, location, direction of view, and more. Much of this information can be automated in a digital camera or other recording device. Photogrammetry refers to the use of photographs to measure distances between objects. Overlays or composite views of photographs can allow different kinds of measurements. Potentially, those measurements could be applied toward creating three-dimensional models of the measured objects in those pictures. The three-dimensional products depend on finding match points among two or more images. Many software programs now can process images automatically from match points and pattern recognition, but sometimes you may need to identify those points manually. In any case, you can achieve better results by recording your photographs with attention to redundancy of information or overlap of the imagery. Ideally, your standardized scale bar reference can be fixed in one position and viewable in each frame. Within photogrammetry, structure from motion has become the most recent standard in three-dimensional modeling. The core concept here is based on the movement of either the photographer or the subject being photographed. This movement or motion is added into the calculation of distance measurements inside a model, effectively mapping the three-dimensional structure of the objects within view. The three-dimensional models, in principle, could be examined to make new measurements and observations independently from the original site documentation. Among the advantages here, the site could be viewed and studied by anyone, without necessarily visiting the site in person, and without losing any information through site deterioration or destruction through time. These records are most useful for situating site elements in their surrounding contexts. Effectively, they add photorealism and texture to ordinary site maps. A similar visual outcome could be possible through video recording, but the three-dimensional models exist within real mapped space. Moreover, the digital models offer a special ability to control the movement and the viewpoint. If the photographic record is compiled in enough detail and with enough overlap among the images, then you can achieve maximum control of the digital model environment. As another direction in digital modeling, three-dimensional site mapping data can be visualized and manipulated in a number of different ways. For instance, the individual elements of stonework ruins can be repositioned into their original configurations. Next, you might perform different experiments with the possibilities of wood, thatch, or other components that have not survived in most archaeological records. Once again, the initial site recording is fundamental for any of these later pursuits. We will continue to see more and more developments in digital site recording, with new equipment, hardware, and software. Meanwhile, this episode has highlighted how sites could be recorded digitally, and what you could do with those digital records. In concluding this episode, now you should be prepared to discuss the potential use and outcomes of digital site records in archaeology. You can evaluate how those records were produced in different cases, and you can assess the potential for new applications. I hope that you enjoyed this episode and that you will explore more with the Archaeology Studio.